Okay, grade 11 analytical geometry. Starting off with grade 10, before we get to new work in grade 11, do you still remember what is this?
It's the midpoint.
To get the midpoint of 2 points. Now, analytical geometry is actually also called coordinate geometry, right? Because coordinate pairs are always at the order of the day. You've got to work with 2 coordinate pairs. So whatever they are, will you be able to find the midpoint? You take the 2 x's and you add them together, you take the 2 y's and you add them together, divide them both by 2. And it's a logical thing. If you know the 2 x's and you add them together and you divide by 2, you're going to get in the middle.
Yes.
Same with the y's, right? The distance formula is actually Pythagoras, by the way. Because if I have to get the distance between 2 points, wherever they are on a graph, and I take the distance between the 2 x's, that's the distance between the 1x and the 1x. Do you agree there? That's the distance between the 2 x's. Do you agree?
Yes.
And for that point there is the distance between their 2 y values. That one's y and that one's y will give me the distance there to make up a 90 degree. So if I want this distance, how do I get it? Pythagoras style. That square plus that square will give me this square. So you just put it in a square.
Roots.
That's where it comes from. Okay, it's just Pythagoras. Then, getting the gradient. Now guys, we've been doing gradient in functions as well. Remember what Nan said to you? If you don't know your straight line, you're not very wise. Because you're going to get it in the functions in algebra, you're going to get it in analytical, you're also getting it in trig. So please know your straight line. So all of the stuff we've done, you know how to get the gradient?
Yes.
You also know how to get the straight lines equation. I mentioned it over here, finding the equation. So they go together, just like in the functions in algebra. Things to remember, if ever I talk about parallel lines, what's the thing that you must know?
Gradients are equal.
That the gradients are the same. Whatever the lines are, the gradients are the same. For perpendicular lines, what must you know?
The gradient should be equal to 90.
The product gives me -1, which means what? If the one gradient was -2/3, then the other one will be positive 2/3. Remember this exact same lesson when we were busy with the straight lines.
Yes.
So then we can get equations, etc. So the moment that you hear something about parallel and perpendicular, you know gradient. If you have to go get an equation of a straight line, you need the gradient. Whether you get it from somewhere or you work it out from somewhere, gradient. Collinear points you did in grade 10 as well. Collinear means they sit together like we are a cooperating group of people here. We work together on the same thing. So if they are co-linear, linear means a line. So if they co-sit on a line, they are co-linear. That's what collinear means. So what are they going to ask me? There's random points and they want to know, do those points sit on the same straight line? We don't try and sketch it. The way to prove that they are on the same line or they're not is to look at the gradient between the 2 points and the gradient between the other 2 points and the gradient between the third pair, and if all of that is the same, then they cannot be other than on the same straight line. If the gradient between all of them is the same. So the reason for all the technique for that is to prove that gradient AB is the same as gradient BC is the same as gradient AC. And very often people say, man, if I only do 2, that's fine. It's not fine. If you only do 2, you have to then say, but B is a common point, and if you don't write that, you don't get the marks. So I taught you in grade 10, which I'm telling you now again, if ever you have to prove collinearity, and never happens almost, but I can never say never, very seldom, very unlikely, most unlikely, statistically 1% if I have to guess. For collinear, that's the way to do it. You always take all 3 pairs, AB, BC, and AC, and if the gradient is the same, then I know that those points sit on the same straight line. In other words, they are collinear. Old work. New work. You must have wondered once or twice in your life already, why don't we work with degrees? So if I say that the gradient is 2/3 or the gradient is -1/3, how steep is that? You're not really getting a feel of it. But if I say that the gradient, positive gradient of 30 degrees, you can estimate approximately approximately 60 degrees, whatever, incline, and incline at the gym, inclination, that's the angle that you're going against. All right, now so, from now on, we are going to ask you to actually work with degrees. So please make a big note of this. The moment that any question in analytical asks you something about degrees, you're going to be working with inclination. Now, the definition for inclination is it's the angle between the positive, listen carefully, focus. It's the angle between the positive x-axis and your line. Now, there's my line. You see the set of axes? So the angle between the positive x-axis and the line, is this still the inclination? Yes. It's formed from the side. It doesn't have to be, you can sit right over here and you can say the angle's there. It's formed from the side where the positive x-axis was up to your graph, up to your straight line. That would be the degrees, and we call it theta, or whatever they like to call it, doesn't matter. Now, there can happen two things. I can have a positive gradient, which will then mean, tell me quickly the logic behind it. If it's a positive gradient, that degrees can only be between 0 and 90. So between 0 and 90, I'll have an acute angle if the gradient is positive. So it's something you've got to know. So when the gradient is 2, m is 2, you're going to have an acute angle. I've got to give you the formula here still. And if there's a negative line, your gradient would be negative, but your degrees. Now, please take note, this is not inclination. Inclination is formed from the positive x-axis up to your line. So this is an what angle? Obtuse angle. So it's between 90 and what? 80. And it can be 90 as well, but then that's a special line, right? If the degrees is 90 degrees. I'm not going to ask you for the gradient in degrees. You're going to know it's 90 degrees. And that means that it's a special line. X stays constant, gradient 0, or y stays a constant. Are you with me? Yeah, everything falls together. But I know that the gradient is negative, means that I'm going to have an obtuse angle. Right. So just to re-emphasize, what is inclination? It's the degrees that your line makes with a positive x-axis. It doesn't matter how far your line is from the positive x-axis, it's still from the direction of the positive x-axis to your line, which means if it's in a positive direction, it'll be an acute angle. Not a cutie pie angle, an acute angle, right? So in the negative direction, your angle of inclination, or your incline, will still be from the positive x-axis, but in this case, if it's a negative line, negative gradient, it'll be an obtuse angle. Now there's a formula to actually work it out. Let's have an example. So you're going to get into sketches like you always have with your analytical, and I'm going to ask you for, find me the inclination of this line. Where is the inclination, by the way? Between the x-axis, whether I draw it over there small, that nobody can see, or draw it over there, that's my angle of inclination. Usually they use a theta, but they can use any symbol. So if I want to work out that angle, I need to go and work with a formula, new formula. Do you see that analytical geometry's formulas?
Yes.
Right. So again, I've got something to do with the gradient. There was gradient formula, there's collinear as a formula, perpendicular as the gradient, parallel as the gradient, inclination, gradient. Do you see it? Gradient, gradient, gradient everywhere. If all else fails and you don't know what to do, please do gradient. You might be right. Okay? So for inclination, I'm needing the gradient of this line. Do I have the gradient of this line? No. I need to find the gradient. How? As the old news, and I'm not writing it over there, I'm saying 6 minus 8 will become? Right? And 3 minus 4? You understand why I'm making those big fat pluses? If you had swapped it around, it would have been -8, -6, -4, -3. And that answer and my answer will be the same. Check it out. So this is 14/7, which is 2. A positive gradient, does that confirm what I've done over here?
Yes, it is.
At least positive. It has to be positive. But now man is asking not for the gradient, I'm asking for the inclination. But you need the gradient for the inclination because the new formula says, once I have the gradient, I can find for
Theta.
theta. So you need to know that for theta, tan theta would be equal to the gradient. And the gradient in this case is 2. How will you get the angle?
Shift.
Shift tan. This is a small little case. You finding an angle. It's type 1, finding the angle. Shift tan is case, finding the angle. Are you with me?
Yes, ma'am.
But then you just say shift tan of 2 and what's your answer?
63,43.
Plus k times 3. No, what's the craziness there? I'm specifically now, practically busy with an angle of inclination. This can only be 63,4. 3, not plus k 180. Where am I going? Inclination can only be an acute angle or an obtuse angle. One answer, boom. Not plus k times 180. Practically that doesn't work for the sum. General solution, yes. Not for this one. Are you with me?
Yes, ma'am.
Only other thing that can happen is that the angle can be obtuse. So you've got to have a negative gradient. Now find me the gradient.
We don't have
Yes, you do. The gradient is negative at 3. I'm giving it to you. You don't even have to work it out. So how would you get to the inclination? Gradient equals tan of theta, and the inclination is negative a third. You didn't even have to work for it, but it's going to be worth marks that you know it, that that's your gradient, and that you've got to put it equal to tan. It's 2 marks. How will I find theta now? Shift tan of what? Just 1/3. That's the way we taught you, right? Just 1/3, because that will give you your reference angle. And the reference angle is, please? 18,43, thank you. Is that your answer then? Definitely not, it's got to be obtuse. So then we usually did then say, tan is negative there and there, which in any case we never wrote, but we wrote for quadrant number 2 that theta, the angle, is then 180 minus that 18,43, which is, please?
161.57.
Plus k 180. Again, it makes no sense to do that. I'm not doing a general solution. I'm finding a very specific obtuse angle. And that's it. 161,57. So you don't do all this stuff, but it's like a little piece of it. Small little keys in between. But like we did when we were busy with type 1, you never put in the negative. You only get the reference angle, and then you're going to get to that answer over there. So that you can find the same technique throughout in everything that you do. Please do it the same way. So no k times 180 or keys or anything in there, because practically it's only an obtuse one answer, not a million answers, only one. Questions? Okay, some stuff that you were taught previously, and I'd just like to remind you on, is if I ask you for the midpoint, you know what to do. But the same thing applies when I give you the midpoint and I want the other point. So if I know that B is the midpoint of AC, how will I find that point? Do it in reverse, right? So you know that 3 and x plus 2 divided by 2 should give you 3 and x plus 2 divided by 2 should give you 6. And 1 and y plus 2 divided by 2 should give you negative. It's the midpoint formula, right? And then let's do our math. 12 because I'm timing. Then I'm subtracting and I'm getting 9. First of all, times by 2, you're going to get negative 4. Then you're going to say plus is going to give me negative 3. So that B or C point. Oh, thank you for helping me. So it's 9 and negative 5 and I'm done. But you can have a shortcut. I want you please to focus on translations. Algebra, anywhere, wherever you are, translations. Because if they sit in the middle, then the same translation that took place there should take place there, because they're exactly halfway apart. What translation transpired from 3 to 6? You said plus 3. So plus 3? From 1 to negative 2 is minus 3. Minus another 3? Saving time. How many marks?
0.
You'll have 2 marks for any which one of these two. That's a whole lot of work for 2 marks. So please will you remember that there are some tricks to the trade. You're going to get 2 marks any which way. Same thing with distance formula. If I gave you the distance formula but I'm asking you for some sort of a variable, how do you do that? It's also reverse. So we know that the distance formula is x2 minus x1 squared plus. And guys, please, if you don't know your formulas, big problem. So we know that the distance is root 80. But we don't know what k is. So if we say k minus 2, and we say 5 minus minus 3, which will be a plus, then this answer should be root 80. So we're solving for k. Focus. We're solving an equation here. Techniques. What's the first thing that I'll get rid of? The 2 roots on either side. Because it's one big fat root on the right and one small little root on the left. If you square it, it's going to be 80, and the root's gone on the right-hand side. But you're going to have to simplify and get k minus 2 squared. Time it out. Well, you can. And this one, 8 squared is 64. What technique is man going for? I'm trying to solve for k. What am I going to do? Square root. It's shorter than all the time timing everything out and factorizing back again. This is a shorter technique. The only problem with this technique is you forget the plus and minus, because when you square root it yourself, there must be a plus and a minus, and then you forget that there should be 2. So it's either 4 equals k minus 2 or negative 4 equals k minus 2. So k equals negative 2 and k equals, how come there's 2 answers here? On a set of axes, if you had 2 and negative 3 somewhere over there, right? 2 and negative 3 for A. I'm saying that it can either be then 6 and 5, which will be 6 and 5 somewhere over there, right? Or it can be negative 2 and 5, somewhere over there. Because the only thing that I'm limited to is that the distance between them must be the same. So there is 2 possibilities. So it's not, I'm sure this is not applicable because it's negative, because that's what most kids do. They find 2 answers and they say the negative is not applicable. There's 2 answers here. Because in practice, can you see how it works? You don't have to sketch it, just to see sometimes there are 2 answers. Okay.